Hi and welcome to this video on GCSE Algebra Maths Made Easy. Algebra questions always appear in the exam, very easy to do, easy marks to pick up if you know how to do them. So in this video what we're going to do is try and go through them step by step. Here we're asked to simplify. When we simplify we collect like terms. And we've got to understand what a term is. A term is separated by a minus or a plus. So this is a term, this is a term, this is a term, this is a term. Like terms have the same, if this is x or x squared, which isn't in this case, or a 4 by itself and a 6 by itself, those are like terms. These, because they've got the x by themselves, those are like terms. So if there was something with an x squared and another x squared, those would be like terms. Then we collect the like terms. We'd collect the 3x plus 5x, then collect the minus 4 and the plus 6. Then we combine the like terms, so 3x plus 5x is 8x, minus 4 plus 6 is plus 2, and we get 8x plus 2. Here we're asked to simplify 2x squared plus 4x plus 12x squared minus 5x. So the like terms are 2x squared, 12x squared, and 4x minus 5x. So group those together. Then combine the like terms. 2x squared plus 12x squared is 14x squared. Plus 4x minus 5x is minus x. So we get 14x squared minus x. We can be asked to multiply out brackets. So here we've got the 4 outside the bracket. So multiplying that out we get 4 multiplied by 3x. So this is multiplication where a number is outside the bracket. So 4 multiplied by 3x, 12x. 4 multiplied by plus 2 is plus 8. So 12x plus 8 when we multiply out the bracket. Here we've got a minus 3, a minus outside the bracket. When we multiply by a minus or a plus inside the bracket, changes the sign. So we've got to be careful of that. So minus 3 multiplied by 2p squared gives us minus 6p squared. Minus 3 multiplied by minus 7r cubed, change the sign, plus 21r cubed. Multiplying out double brackets, I always like to draw this like a lobster claw, just as an aid. So let's just go through that. So a multiplied by a is a squared, b multiplied by a is ba. Then b multiplied by b is b squared. Then b multiplied by a is plus ba. So this is what we get. And then when we combine the like terms, there's an a squared, a b squared, and there's two lots of ba, so that's 2ba. A squared plus b squared plus 2ba. In this case, we're multiplying out a plus b multiplied by a minus b. And when we do that, we get a squared plus ba minus b squared minus ba. And this gives us a squared minus b squared. This is called the difference of two squares, quite important, because whenever we get something in this form and we want to then factorize it, put it into brackets, it becomes a plus b in bracket and then a minus b in bracket. Here we've got 3p minus 2 multiplied by 2p plus 1. Let's go through our form here. 3p multiplied by 2p, 6p squared, minus 2 multiplied by 2p minus 4p, 1 multiplied by minus 2, 1 multiplied by 3p plus 3p. Combine the like terms, 6p squared minus p minus 2. Factorizing, again, commonly asked. The method for this is, first of all, we look for common factors which must be in all the terms. And then firstly look for a monomial, then we look for a letter, and then we look for a power. So let's have a look at this. 15x plus 10, look for a monomial, so which is a factor, so 5 will go into 15, 5 will go into 10, so write that. And then look at the x. Is there an x? No. So that's the only factor in both of the terms. Then what do we multiply by the 5 to get 15x? Well, that's 3x. What do we multiply by the 5 here to get the 10? Well, that's 2. So this 5 is common. It's a common factor, so we write that outside the bracket by itself. And then 3x plus 2 in brackets. Again, in this example, let's look for the monomial, which is a factor. So 4 will go into there, 4 will go into 8. So write our 4. And then look for the letter. So is there an x in both terms? Yes. So x is a common factor. So write that outside by itself. Here we are. So we've written that there. And then what do we multiply by the 4x to give us 4x? Well, that's 1. What do we multiply by the 4x to give us 8xy? That's minus 2y. Put that in brackets. Okay, let's follow this again. Look for common factors. Monomial first. Is there something that goes into all? Yeah, there's a 6. 6 will go into 6. 6 into 30. 6 going to 12 twice. So 6 is a factor, a common factor. X, yeah, there's an x in all terms. Then look for these powers. There's powers in all of these x's, or attached to all of these x's. So use this least power. So this is x squared, x to the power 2. So write that on the outside of our brackets. Then, as we did here, what do we multiply by 6x squared to give us 6x to the power 4? Well, that's x squared. What do we multiply by 6x squared to give us 30x cubed? Well, that's 5x. What do we multiply by 6x squared to give us 12x squared? That's 2. So put that in brackets. If you want to double check that you've done it right, you can always multiply out the brackets with the rules we did earlier. Multiply out the brackets and you should get that and that as your answer. Okay, let's go through that again. We're going to look for a common monomial, a number. So will 4 go into a 4? Yeah. 4 go into 8? Yeah. 4 go into 12? Yeah. So 4 is our common factor. X, no, there's no x's in all of those terms, so x isn't a common factor. So 4 brackets. What do we have to multiply by 4 to get x squared, or actually minus x squared in this case, because don't forget this minus. So that's minus x squared. 4 multiplied by minus x squared is minus 4x squared. What do we multiply by 4 to give us 8x? That's 2x. 4 multiplied by 2x gives us 8x. What do we multiply by 4 to give us minus 12? So that's minus 3. 4 multiplied by minus 3, minus 12. So if we multiply out this, we get our original 3 terms. In this case, we're given a binomial. So remember, like this in brackets on the top, we had this. So this is a common binomial. We can put that on the outside, y minus 3. And there's 2s plus 5 in the second lot of brackets. And that's factorized. So the binomial in this case acts like a letter or a number, and we can, because it's common in both terms, it's a common factor, we can have it by itself to start. If we've got 4 terms, so here we have 4 terms, there's no common monomial in all 4 terms, there's no common letter in all terms. What we can do is sort of group them into 2. So here I've put this group with the s cubed and the minus 5s squared, and this group with the plus 6x minus 30. And then we factorize those 2 groups separately. And what we get is, with this group we get s squared, s minus 5, and here plus 6, s minus 5. Okay, so we get s minus 5 as our common binomial. Take that out by itself. And then s squared plus 6 in brackets. Here, when we follow the same rules, we get for 8x to the power 4 minus 4x cubed, we get 4x cubed, 2x minus 1. And here we get 6 minus 2x plus 1. But these two binomials aren't the same. However, if we look at it, we can make them the same by changing this to a minus. But when we do that, we have to change the signs inside the bracket. So this becomes 2x minus 1, and here we've got the same binomial here and same binomial here. Common, take that out, put it here, and then 4x cubed minus 6 in brackets. Can't we do that if there's 4 terms? Okay. Most mistakes students make are in simplifying algebraic fractions. So what we're going to do is first of all look at how we treat normal fractions and then extend that to algebraic fraction. And the rules are the same, but we just got to make sure we understand the rules. So 4 divided by 6, normal fraction. So easy, just divide by 2, we get a 2 here, divide by 2, we get a 3, answer is 2 over 3. But what does this actually entail? What we're actually doing is we're splitting the 4 into 2 factors, 2 multiplied by 2, and the 6 into 2 factors, 2 multiplied by 3. So when we multiply these together, so the 2 over 2, 2 over 3, we get the original 4 over 6. So 2 multiplied by 2 is 4, 2 multiplied by 3 is 6. However, here the 2 over 2 is just a 1, and then we can ignore that, and then the answer is just 2 over 3. So this is the method we're going to follow. We're going to have, when we simplify algebraic fractions, one term on the top, one term on the bottom, then we can simplify, and then common factors we can cancel, okay, to give us our answer. So here we're given x squared minus 6 x squared minus x minus 6 divided by x squared minus 4. Most students be tempted to just cross these x squares out, but you can't do that, because to do that, what you're thinking or what they're thinking is that you got this x squared over the x squared, which you can cancel. Yeah, that you can do that. But what's the other fraction? Well, the other fraction then has to be the rest of this minus x minus 6 divided by minus 4. And when you multiply across, you don't get this original numerator. So you can't do that. So for this equation, we have to convert it to one term on the top and one term on the bottom, as we explained. So how can we do that? So we factorize. So when we factorize this, we get x minus 3, x plus 2. So the factors of minus 6 are minus 3 plus 2. And then when we factorize this, this is the difference of 2 squares. So this would be x plus 2, x minus 2. And hey presto, these two factors are the same and we can cancel those. And we get x minus 3 as x over x minus 2 as our answer. So this is equivalent to this when we simplify it. Okay, let's have a look at this example. X plus 2, x plus 3, x plus 2. Oops. Okay, so we can just think of this as one term and this as one term, but however we can think of this as having a 1 here next to the 1 outside the bracket, 1x plus 2. Okay, and then we can cross off the x plus 2 and the x plus 2 as common factors, and we're left with 1 over x plus 3. So that would be our answer. Okay, so 4x plus 8 divided by 4. We've got two terms on the top and one term, so we can't cancel out. So what we've got to do is convert that. If we did this, can't do it. It's wrong to do that. So what we have to do is convert this into one term at the top. Do that by factorizing. So take the common 4 out, left with x plus 2. That's now one term. Divide by 4. Cancel the 4's and we're left with x plus 2. Here we've got this x squared minus 4x plus 3 over x minus 2x plus 3. Students would be tempted to cancel these x plus 3's out. Don't do that, okay, because as we explained, if you're going to do that, you're thinking of it as like this, x plus 3 over x plus 3, so common factors over each other, so you can treat that as a 1. However, in order to do that, you'd have to have this x squared minus 4 over the x minus 2, and when we multiply across these numerators, you don't get x squared minus 4 in brackets x plus 3, do you? So this is wrong. Okay, it's wrong to cross these out. What we have to do then is convert these into a form where there's one term on top, one term on the bottom. This is already one term on the bottom, so we're just concerned with the top now. So multiply this minus 4 out with these brackets, so we get minus 4x minus 12, so we've got x squared minus 4x minus 12. Factorize that numerator, and we get factors of 12 as plus 6 minus 2, which add up to minus 4. So the factors of x plus 6 in brackets, x minus 2, those are our roots. And then, because we've got this x minus 2 factors, one term, we can cross off, cancel those two to give us 1, and we're left with x plus 6 over x plus 3. Again, here we've got x squared minus 3x over 3x minus 9, so don't be tempted to try and cancel anything out. Here we've got two terms, and here we've got two terms, but we want to make it into one term and one term. So how do we do that? Factorize x minus 3, that makes it one term, take the 3 out, x minus 3, another term, 1 over 1. Then we can cancel these x minus 3's, which are a common factor, and we're left with this x over 3. Okay, this one is quite easy to do, but I just want to explain the theory behind it, again like we've been doing. So we could just say 3 into 15 goes 5, then a cubed divided by a squared, 3 minus 2a, then b squared divided by b, that's 2 minus 1, which is the powers, gives us 1, which is a b. However, when we think of it this way, this tells us why that works out. So the 15 we look at as factors, 3 multiplied by 5. The a cubed as a squared multiplied by a, and the b squared as b multiplied by b. And then this 3 by itself, the a squared under the a squared, and the b under the b. And can you see that these cancel, these cancel, these cancel, leaving with 5ab. Going to look at some multiplying algebraic fractions, again related to normal fractions, so we're going to compare. So when we do a normal fraction multiply together, we multiply the top and the bottom separately, then cancel. So here 2/5 multiplied by 4/3, we multiply the 2 by the 4, get 8, multiply the 5 by the 3, get 15. Answer is 8 over 15. With algebraic fractions it's the same. So we're going to multiply this pt by this numerator, we're going to multiply this denominator by this. 25 p squared multiplied by p is p to the power 3. T multiplied by t is t squared, and w by itself. 5w squared multiplied by 4 is 20w squared. So numerator, denominator. Then we can cancel. So we got 5, common factor, common monomial. So 5 goes in 25 5 times. 5 goes in 24 times. And then we've got this w. So w to the power 1, w to the power 2. 1 minus 2 when we divide is minus 1. So we could write here w minus 1 but that is just 1 over w, so we write the w on the bottom. When we're dividing normal fractions, we get 2 quarters divided by 1/3. What we do is, with normal fractions, we turn this second fraction upside down, so this becomes 3 over 1. So 2 quarters, and then we multiply. So 2 quarters multiplied by 3 over 1. 2 multiplied by 3 is 6. 4 multiplied by 1 is 4. And the answer is 6 divided by 4. Do the same with these algebraic fractions. So we're going to turn this fraction upside down and multiply. So this becomes 5s minus 3 on the bottom, 3s plus 4 on the top, and then we've got this and this, which we can cancel out, this s plus 4, and we're left with 3 multiplied by 3, which is 9, and this on the denominator 5s minus 3. Okay. Adding and subtracting algebraic fractions, slightly more complicated, but let's go through the method. First of all, let's go through our normal fractions. When we add, we get a common denominator, and how do we get that? We multiply the denominators. So 5 multiplied by 3 is 15, gives us our common denominators, and then we multiply the 3 by the 2, we cross multiply. 3 multiplied by 2 is 6, and then 5 multiplied by 1 is 5, and then we can add the numerators. The denominators we leave as it is, so we leave that as a 15, and then add the numerators, which is 6 plus 5 is 11. Okay, so let's follow the same method for our algebraic fractions. So first of all, we need to get a common denominator. How do we do that? We multiply these two denominators. So 5 multiplied by 3s plus, that gives us our common denominators. Then we need to adjust the numerators by multiplying the 3 by the 3s minus 4 and the 5s multiplied by the 5. So we cross multiply. So this is what we get. 3s minus 4 plus 25s. When we multiply by the 5s, we get 25s. Okay. Multiply out the brackets here, and then leave the denominator as it is. We don't do anything with the denominator, we just write it once underneath because it's common to both. And then when we collect like terms, we get 9s plus 25s, 34s minus 12. Okay, slightly more complicated, but we're going to follow the same rules. So our common denominator is going to be the numerators multiplied together. So here we've got the two denominators multiplied together, 4x minus 1, x plus 3, 4x minus 1, x plus 3. Cross multiply the x plus 3 with the 2x minus 1. We get 2x minus 1 multiplied by x plus 3. Cross multiply the 4x minus 1 by the x plus 2. We get 4x minus 1, x plus 2. Multiply out the brackets. We get here 2x squared minus x minus 3 plus 6x. Multiply out the brackets here. Minus 4x squared minus x minus 2 plus 8x. Don't do anything with the denominator. Leave that as it is, but just write it once because it's common. So just write it once here, and then collect the like terms on the top on the denominator, and here's the answer: minus x squared plus 12x minus 5 over this denominator, 4x minus 1, x plus 3.